So we want to graph r equals 1 minus the cosine of theta. So the first thing to notice is that we're just going to list the easy values of theta. We don't need to worry about pi over 4 and pi over 6 and pi over 3. While it will make it a little more accurate, it's not necessary. So the first thing I've done is I've listed the values of theta, and then I've listed the values of 1 minus the cosine of theta. So now if we come over and we just look at our graph here, we're going to just trace it out. So it's already graphed here for us, but we're going to move the angle. And so the cosine, when we start out, is 0, because the cosine of 0 is 1, and 1 minus 1 is 0. And then watch as my radius grows. Okay, my cosine value gets a little bit smaller, so 1 minus it gets a little bit bigger, and I'm tracing out those points until I get to pi over 2, which has a cosine value of 0, so 1 minus 0 is 1. So I'm right up here. So what happened is as I went around all my radii here, as I went around, my cosine was getting a little bit longer until it's at 1. Now the next value that I have over here is at pi. Okay, so when my radius gets all the way over here to pi, I'm going to have an r value of 2 when my angle gets over to pi. So what's happening? Well, as I trace from pi over 2 to pi, 1 minus the cosine of theta is getting longer because the cosine is negative here. So it's getting longer, a little bit longer, a little bit longer, out here at pi where it's 2. So if I've just plotted this point and this point, I know that it's just going to follow a curve going out there. Same thing, the next point I have is 3 pi over 2, which has a cosine value of 0, so 1 minus that is 1. And look what's happening is my values here are getting, sorry about the blinking, my values are getting shorter. So again, my radius is continuing around. The 1 minus the cosine of theta gets shorter until I get to 3 pi over 2. And then lastly, at 2 pi, I'm back at 0. So my radius continues to get shorter, going right around there.